Hey guys, welcome back to Algebra 2. Today we're going to talk about how you solve equations and inequalities by graphing. And the notes today are going to be on page 33 in your workbook. And this is all about how you can solve equations by using a graph. Now, you might think, okay, well, I have already solved equations like this, 3x plus 7 equals 4x plus 5. You already solved that before, but sometimes the equations can get much more complicated. Like what if I have absolute value bars on one side, and what if I have 4x squared on the other? And then the solving process gets a little more complicated. So if you can solve by graphing, then it makes it a lot faster to solve the equation. So let's flip the page and we'll look at a couple examples. So on the next page, let's look at example 1. Now example 1a, 5x minus 12 equals 3. I know that you guys can solve this in your head already, but we're going to use it as an example and go from there. Okay, so if you want to solve these by graphing, first of all, we're not going to graph anything by hand. We are going to graph everything on our graphing calculator and use that. So there's no need to have to graph it by hand. But you are welcome to use this space right here to draw a picture to help you remember in your notes. Okay, so the way that you solve by graphing is number 1, you're going to graph y equals the left side of the equal sign, and then you're going to graph y equals the right side. So that means for this part A, I'm going to be graphing y equals 5x minus 12, and I'm also going to be graphing y equals 3. Now, once I graph those, I'm going to be able to find the solution by looking for, if you notice it's an equal sign, I'm going to be looking for the place where 5x minus 12 is the same as 3. So for part 2, the place where they're the same is the point where the graphs intersect. So step number 2 is look for the point, and sometimes it's more than one, where graphs intersect. Okay? Then, not only is it enough to look for where they intersect, but if you notice, our equation only has one variable, which means our answer only has one variable. So step 3 is really important because, yes, you can find the point of intersection, but to get the answer, you need to know if it's the x or the y. So if my equation is in x's, then the answer is the x coordinate. Now, let's see what this looks like in Desmos. So on one side, I'm going to graph y equals 5x minus 12. My next line is going to be y equals 3. Sometimes you'll have to move the zoom or change the window where you can see. Okay, so that's step 1, graph the 2. Then I have to figure out the coordinate of the intersection. So I'll click on there with Desmos, it's intersecting at the point 3, 3. And then step 3 says the answer is the x coordinate. So the answer to that is x equals 3, which you probably already knew because you probably already solved this in your head, but I can just look at the graph and say, well, hey, x equals 3 by looking at the graph. Now, let's look at the second example, and I'm just going to go straight to the graph here. So I'm going to graph the left side and the right side on Desmos. I'm going to graph y equals negative absolute value of x minus 2. Oh, look, it's absolute value. And then I'm going to graph y equals negative 1/2 x minus 2. And I look at the graph, and I can hide the equations line if I want to. Look at the graph, hide the equations line. Then I can really zero in on what the points are. So I'm going to click here. There's a point. There's a point. So it's possible that the equation has more than one solution. This, since there are two intersections, and then I might even want to zoom out to make sure that the graphs don't ever intersect again, but they don't. There's only twice. But the x-coordinates of each intersection are my solutions. So for part B, x equals 0 and x equals 8. Now, probably it's a good idea for you to sketch these pictures on your notes, but look how fast it is to solve. You just graph and look for the answer. Isn't that amazing? Now, we can also do this with inequalities. You just have to be careful about what you're looking for. So for inequalities, step 1, you're still going to graph y equals the left and y equals the right, and L for left, R for right. Step 2, you're going to have to see which part satisfies the inequality. So look for the intervals that satisfy the inequality. And let me pull up Dismos and show you what I'm talking about. So let's type in y equals the left, x squared plus 6x plus 5. And then we'll type in y equals the right, and this time the right is 0. And I'm going to come over here, and I'm going to hide the inequality so I can look better. And now I'm looking for the part where x squared plus 6x plus 5. Now that is the parabola, so that's what's in red, where that is greater than or equal to 0. So in other words, I'm looking for, it might be helpful if we label these a little better. So this part is the parabola. So I'm looking for where the parabola is greater than or equal to, and the 0 is actually this time on the x-axis. So I'm looking for where the parabola is greater than the x-axis, which is very similar to our positive and negative intervals that we had before. So let's see, it's greater than the x-axis here and here. But then it also asks where is it also equal to the x-axis, so I also need to include these endpoints. So I'll say that the parabola is greater than the x-axis, or x squared plus 6x plus 5 is greater than or equal to 0 on the interval from negative infinity. This pen is too thick. On the interval from negative infinity until that point right there, negative 5. And I do want to include it because it says or equal to. And that point right there, negative 1 to infinity. And let's do example B too. So scroll over to B. Let's graph B. I need my pen to come back up. There we go. So I'm going to graph those two functions. Delete what I had. I need to erase this stuff. Okay, so I'm going to graph y equals x plus 3. That's the left side of the inequality. And then I'm going to graph y equals 7x minus 3. So this time I've got two lines. Can be a little bit different, so I'm going to color code a little bit. So the x plus 3 is the green one. The 7x plus 3 is the purple one. So I'm being asked, when is the green line higher than the purple? In other words, when are the y values for the green line higher than the y values for the purple line? So let's look, and I'm going to need to give an interval. So if I look, I see that they connect right here. That's when the y values are the same. The y values here are both 4. But then if I compare, like, let's see, it might be difficult to see because they're kind of going off. Let me do this. Let's say when x is 0 on the green graph, the y value is 3. When x is 0 on the purple graph, the y value is -3. So you see how the y value is higher for the green here than the purple? But then if I go over to the second part, the y values for the green are lower than the y values for the purple. So the y values for the green are greater all along this part right here. So that would be the interval from -infinity all the way until where they connect. So I will say the green is larger than the purple from -infinity until where they connect at x equals 1, and it has a greater than sign, so I don't want to include it. Now let's look at example 4. We need to use graphing technology to approximate the solutions of the equation. So it's an equation this time, so I'm looking for the point where they're equal. Notice that they're an equation. So if you see an equation, you're going to have a point. If you see an inequality, you're going to have an interval. So I'll graph each side of the equation. Y equals x squared plus 2x minus 1. Then I'm going to graph y equals the absolute value, well, that's a minus, equals absolute value of x plus 2 plus 2. And I notice that there are 2 intersections. I'm going to zoom out just to make sure there's no more intersections in that. And remember, the x values are your solutions. Now this one, it's further along in the examples because the solutions are approximate, they're not exact values. But it does say approximate the solution to the equation to the nearest tenth. So that's the first decimal. So we'll write that our solutions are x equals -3.03, but that's approximately -3.3. And then the other one, 1.791 rounds to 1.8. I don't really need that part. Now look how cool it is. You just look at the equation, then you look at the graph, and then you write your answer. So it's really quick today. So that should be enough for you to be able to go on to Savas and do your 1-5 assignment. Again, if you need